morning. We're going to try to do this presentation in English with a slide in French, so you can follow up. At the end of the presentation, if anybody wants a copy in English or in French, we can drop them. Okay, we're going to look at a case study on a product that we call L'Arpenter that has been developed today for the transport of person, but the base of this product can be changed to incorporate more of sensors and robotic solutions that are on offer today. And as we really feel like there is not such a thing as a normal person, we felt that it was by resolving the problems of each individual that we could possibly increase everyone's well-being in the town. So we went on thinking about a vehicle that first will keep the proportion of the man. He must be able to have similar activities than walking, or support the activity of walking for people that cannot fully perform these things. For example, carrying heavy loads, or people are tired, people that need to find their own way, possibly people that got visual or physical deficiency as well. And it was very important to us that the user will be using a stand-up position and try as much as possible not to be taller than anybody else, to stay at the same level. And one of the other things is that if we were going to design a product that had to be used in town, then it had to look right in town. So I guess some of you have been thinking about another two-wheel gyroscopic vehicle, as we can think, and we have been thinking about that as well. And the product that we wanted to have was something that would be reassuring, not something boring. We've done that by having the speed that was probably matching the walking speed, and also by the softness of the acceleration and deceleration. It is a vehicle that has got to reassure the user and reassure the people that are around the vehicle in town. That was very important. And really what we try to do is to get the person using the vehicle to feel integrated in town, not rejected in town. And by the solution that we've come with, we feel like it builds on the existing resources like the car, the public transport, the bus, the train. And it is also an answer to a fairly large population. It's not for disabled people, it's not for elderly, it's not for young people. It's trying to get and reach every market in that way. Something that can help in both situations, inside, indoors, or outdoors. In the development, we also aim at meeting ecological criteria. First of all, we started with electricity, electrically powered vehicle. There is a lot of recycled material here. There is a lot of aluminium, for example. Also in the design, we designed a vehicle that can be assembled in a very small workshop. So there is no specific skills on there. It can be put together by a cycling shop or any garage, or maybe a workshop from a town. And what we wanted to have is something that could be assembled close to the place where it is going to be built, so in town. We also felt that it was important not to consume any more space. So there is no specific change in the time that needs to happen. This vehicle can go wherever a pedestrian is able to go, except maybe a few steps, but have to be sorted. Okay, so some of the characteristics of the product, the speed is limited to 6 or 10 kilometers an hour, so it can go to any area. It's got a very small turning radius of 1.1 meter, so it can be used inside the house without any difficulties. And it can carry a fairly heavy object between 40 and 60 kilo, and the payload of the vehicle is 140 kilogram. It's got four-wheel steering, controlled by electric geared motor, and there is a choice of working with 1 to 4 electric motor between 100 and 280 watt each. So there is a fair amount of power here. And one of the big advantage of this vehicle is driving accuracy because of the four-wheel drive. It can go along and keep a very good trajectory, even on slope. It's extremely stable, and especially because of the four-wheel being of the same diameter, and the wheel also sticking out of the vehicle, so making use of bumper if required. And really, it is something, when you see people using it, it's a little bit like, we like it to be compared to a personal conveyor belt. This is what the image that we like to have in this way of using, and its safety. Okay, the assembly, again, is very simple, and with very reliable parts. We think that it can be built in any workshop with just a very simple manual and maybe one day of training. So it's a very, very simple technology, as you see on this image. So we got a similar version to the one presented here. We also got some idea of how the product can be equipped with a backrest, for example. But this model, the Arpenter, could also have a GPS, could have some electronic bumpers, could have some camera added on. So this is just the basic development of that type, but there is a lot of other idea coming. For example, transporting some heavier load, or baby seat, or mail bag, or toolboxes. Okay, now in the next 5 slides, we're going to look at the mobile base, which was the starting point of this vehicle, and try to explain how we would like to move forward and developing and carry on developing this type of product. So the mobile base is just pretty much this, without the arch on the top and the body shell. There is underneath battery drives, and this is a sort of basic building blocks that can be modified to support and suit a lot of application. We've been thinking about using in industrial environment for robotic workshop, for example, a mobile base for access to some hostile or contaminated area with a remote control. Has been suggested to be used on logistic platform for picking orders, for example, and some interest in agricultural application as well as hospital and airports. So for this, we would like to invite some interested parties in developing it further to create multidisciplinary teams. Hopefully made of end users, but also some system integrators and some automation or electronic engineers. And the last step is to get someone to start manufacturing or supporting the manufacturing of the product, the prototype, and finalize the industrialization. So as a conclusion, we've got 2 lines of work. One is the Arpenter, which is a product that is fairly well defined, I think. And then the BMR 33, the base. We're not completely fully aware of all the possibilities that are open to us with what we can do, and with the development of new sensors and technology. I think that the limits are endless. And we are open to discuss any way forward to take this platform into the next generation of product. Okay, so we're at the end of the presentation. Thank you very much for your time and listening. And if you got any question, do feel free. If you want a copy of the presentation as well, come and find me. Thank you.